Okay, this is the last lesson in Unit 3 for geometry. The lesson is called Composite Transformations. So far we've done 4 types of transformations. We've done translations, we've done reflections, we've done rotations, and we've done dilations. And now these are called composite transformations. So a composite transformation I'm around the room. I fit it nice. A composite transformation is a combination of 2 or more transformations. Okay, you might also hear this called a composition. Okay, in a composition, each transformation is performed on the image of the preceding transformation. So if you take a pre-image and you do a transformation on that, the next transformation is going to be on your second figure, not the original one. Okay. So example 1, we're going to start with some easy ones with just some points, just to get you in the swing of things. Okay. The point 3, -2 is rotated 90 degrees counterclockwise about the origin, and then it's dilated from center 0, 0 by a scale factor of 5. What are the coordinates of the resulting image? Okay. So first we are rotating 90 degrees counterclockwise. So the rule for that, if you remember back to lesson 3, rotations, a 90 degrees counterclockwise rotation rule is xy maps onto opposite y, x. So first, 3, -2 is going to map onto opposite of y, x. So that'll map onto 2, 3. And so that's the first part. But now we are going to dilate it by a scale factor of 5, centered at the origin. So the rule for that will be xy maps onto 5x, 5y. Well, you're starting from here, okay? Not from the original point. You're starting from here. So it'll be 2, 3 maps onto 10, 15. So I'm just going to say the coordinates of the image are 10, 15. Okay, so we're just starting off with some nice easy ones before we get to like triangles and quadrilaterals and whatnot. Okay, so we're just doing just a specific point. Okay, so example 2, the point 1, -5 is reflected across the y-axis and then rotated 270 degrees counterclockwise. You just have to make sure you go in the right order. The order matters. Okay, maybe not every time. Sometimes if you make a mistake in the order, you might still end up with the right answer. But in general, the order matters. Make sure you go in order. So first, reflect across the y-axis. So the rule xy maps onto opposite xy. So 1, -5 maps onto -1, -5. And then rotate 270 degrees counterclockwise. So that rule, the xy maps onto y opposite x. So again, I'm starting with this one. -1, -5 maps onto -5, 1. So the coordinates of the image are -5, 1. Okay, one more. The point -8, -6 is reflected across the line y equals x and then dilated by a scale factor of 1/2 with center 0, 0. What are the coordinates of the resulting image? So again, go in order. First, it's reflected across the line, y equals x. So that rule, xy maps onto yx. So -8, -6 is going to map onto -6, -8. And then dilate it, scale factor of a half. So xy maps onto 1/2 x, 1/2 y. And again, I'm taking this point, -6, -8. And that maps onto -3, -4. Okay. The coordinates of the image are -3, -4. Okay, now the next page, there's, it's the same idea, but now we're going to be doing it with triangles. And I gave you tables, okay? Graph the following composite transformation. Rotate 180 degrees around the origin, and then translate it so xy maps onto x, y minus 5, okay? So again, let's go in order. You have to go in order. First, we are rotating 180 degrees. So for my first table, I'll do xy, the rule, maps onto opposite x, opposite y. Let's go in alphabetical order, RST. Map onto R prime, S prime, T prime. Okay, so R is -2, -3. It's going to map onto R prime, 2, 3. S is -3, 0. Map onto S prime, which is 3, 0. And then T is above 2, -2. It's going to map onto T prime, which is -2, 2. Okay, now you do not have to actually graph this if you don't want to. I'm just going to graph the final image. Okay, I'm not going to graph R prime, S prime, T prime. Okay, but now what we're going to do above is now we're going to do a translation. So it says above, now we're going to do a translation. XY maps onto X, Y minus 5. XY maps onto X, Y minus 5. And here's what I'm going to do. My left column, I'm going to use R prime, S prime, T prime. And I'm going to call it, I'm going to say R prime maps onto R double prime. I'm going to say S prime maps onto S double prime. And I'm going to say T prime maps onto T double prime. So I'm going to copy R prime, S prime, T prime from this table. Okay. So R prime was 2, 3. We had S prime as 3, 0. We had T prime as -2, 2. So the translation, leave X alone and subtract 5 from Y. So 2, -2. This one will be 3, -5. And this last one will be -2, -3. And that's what I'm going to graph. I'm going to graph the double primes. So first one, 2, -2. Is right there. 3, -5. And we have -2, -3. Okay, now let's label them. So this one down here, this is S double prime. This one was T double prime. Same vertex as R, same point as R. And this one right here was R double prime. Okay. All right, we got one more like that. Example 5. Okay. First, we're going to do a translation. So translate xy maps onto x plus 3y, and then reflect across the x-axis. So translation first. Okay, so the translation it said to do is xy is going to map onto x plus 3y. Let's go in alphabetical order. FGH going to map onto F prime, G prime, H prime. F is negative 1, 2, 3, 4, negative 4, negative 4. G is negative 2, negative 2. H is negative 5, negative 3. So add 3 to the x and leave the y alone. So F prime will be negative 1, negative 4. G prime will be 1, negative 2. And H prime will be negative 2, negative 3. Now again, you don't have to graph those if you don't want to. I'm just going to graph the final image. Next, we are going to do a reflection across the x-axis. So reflection across the x-axis in this table down here. The rule will be xy maps onto x opposite y. So I'll put F prime, G prime, H prime. I'll say it maps onto F double prime, G double prime, H double prime. And F prime, G prime, H prime, I'm just going to copy them from this table right here. Okay. Some people like to do it all in one table. I like doing 2 different tables. That's just my preference. Okay. So F prime, copying from above, is negative 1, negative 4. G prime, copying from above, is 1, negative 2. And H prime, copying from above, is negative 2, negative 3. I'm going to map onto x opposite y. So F double prime, negative 1, 4. G double prime, 1, 2. And H double prime will be negative 2, 3. And these are the 3 I'm going to graph. Okay. So negative 1, 4. You got 1, 2. You got negative 2, 3. So there we go. Connect these. And label the vertices. So negative 1, 4. This one is F double prime. This one was G double prime. This one was H double prime. Example 6. Write a list of at least 2 different transformations to move from point A to point D. So you have to move from point A to point D. You have to have 2 different transformations, meaning you cannot do translation, translation. You cannot do reflection, reflection. You have to do 2 different types of transformations. And then you have to write a list of at least 2 different transformations to move from point B to point F. Okay? So let's start with moving from point A to point D. Do that one first. So I'm going to say moving from point A to point D. That one first. And then we're going to do moving from point B to point F. So there are 2 different problems here. Okay. But let's start with moving from point A to point D. Okay. If you want to move from A to D, think about it like this. Again, it says you have to have two different transformations. It is difficult to reflect to an exact location. It is difficult to rotate to an exact location, but it is easy to translate to an exact location. So always end with the translation, okay? Always end with the translation for these, okay? So for example, for this first one, moving from point A to point D, let's do a reflection first. So what I'm going to say is, let's reflect point A, ignore the voice crack in the video. Let's reflect point A across the y-axis. Okay, so I'm going to say, let's reflect across the y-axis. So look what I'm doing. I'm writing out in words what I'm doing first, and then I'm going to write the rule. The rule for that will be xy mapped onto opposite xy. And now let's use the coordinates. So A was originally at 1, 3. So 1, 3 is mapping onto -1, 3. So I'm going to do is I'm going to put a star right there. That way I know where I am. And that's where I am right now. Okay, and now, like I said, it's easy to translate to a certain location. So next I'm going to say we're going to translate. I'm going to write it in words what I'm doing, then I'll write the rule, then I'll use my coordinates. I'm going to translate from my star to point D, will be left 1, 2, 3, down 1. Okay? From the star to D, left 1, 2, 3, down 1. So I'll say translate 3 units left and 1 unit down. So as a rule, that's going to be xy maps onto x minus 3, y minus 1. So that means -1, 3 from right here is mapping onto -4, 2. I don't know why that took me so long to do. I was thinking about something else right there. Okay, but anyway, -4, 2. You see that is point D. So that one is done. Okay? So we have to do the same exact thing to move from point B to point F now. But again, the directions above said you have to have two different transformations. So you cannot do reflection, reflection. You cannot do rotation, rotation. You cannot do translation, translation. So this time, let's do a rotation. We're going from B to F. Okay, we're going from B to F. Let's do a rotation this time just to switch it up. Okay, you can do whatever rotation you want. I'm going to say, and again, you can make it as easy or as difficult as you want. So I'm going to say rotate 180 degrees around the origin. If you want to be crazy, you can rotate around a point that's not the origin. I'm going to rotate around the origin. Let's keep it simple. Then I'll put the rule. XY maps onto opposite X, opposite Y. And let's apply it to our coordinates. So we're going from B to F. So B is at 3, 1. So 3, 1 is going to map onto -3, -1. Let me label that in the diagram so I can see where I am. Right there. And now we want to get to F, so let's end with a translation. You're going to translate 2 units down to get to F. So I'm going to say translate 2 units down. I'm going to write that out as a rule. XY maps onto X stays the same, Y minus 2. So that'll mean if I'm starting at -3, -1, And that is mapping on to -3, -3. Which you can see above brings you to point F. So again, that's what those questions were asking. Okay? And that is actually the end of lesson 5, composite transformations. And that is actually the end of the entire unit. That is the end of unit 3, transformations.